Hello again. Week 2. I think I'm going to do 2 videos this week. This is going to be the first video. Shouldn't be too long, but it's going to go over proof of the Big Bang. Now, you can talk about the Big Bang all you want, and you can talk about anything all you want, but if you can't prove that something happened, then why are you even talking about it? So, in this case, I just want to start by just looking at this picture here. My friend took this picture on a camera with one of those, those giant lenses. Had a giant lens on it, and this is actually a picture of Andromeda. Andromeda is the nearest galaxy to the Milky Way galaxy, and in about 5 billion years, they're going to collide and intertwine, and they'll make a new galaxy. It's going to be really, really cool. We won't be there, but that's alright. Just to give you a relative size, here's the size of the moon, and if you could see Andromeda with the naked eye, this is how big it would be in the sky compared to the moon. And this thing is, I think, like 30 million light years away from us, something like that. That number may be off. I've got to double check that. But that's just, it's huge, it's gigantic. And you can't really see it with the naked eye, but with a special lens and an open camera that you hold down the camera button for a while, it lets enough light in so you can actually take pictures of it, or with the telescope. Alright, so let's get into proof of the Big Bang. First off, back to Earth science. We know that the universe is expanding and getting bigger, right? So if it's expanding and getting bigger, that means if we play that in reverse, right? If we go back in time, everything starts to come together and coalesce into one tiny spot, right? But how do we know that the universe is getting larger? So, to help explain this, take out the whiteboard. Alright? And it's the idea that you'll see this in the Nearpod when you're asked about the wavelengths of light, proof that the universe is expanding. You'll see that different colors have a different wavelength, right? So a long wavelength color that is visible to the eye is red. Red is the longest wavelength that the human eye can see. One of the shortest wavelengths, other than purple, the second shortest wavelength is going to be a blue wavelength. So the main point here is that light makes colors in the human eye by providing a certain wavelength. The human eye and the brain then translate that into different colors. But imagine if I had this blue light here, right? And think of it as like an accordion or a slinky, that if I pulled this and stretched this light out, it would eventually match the length of the red light. And if that light is coming into our eye, that means that an object is going to be moving away from us or have a red color. Main point here, if an object is moving away from you so fast that its light gets stretched out, that gives it a red shift, meaning that the light is closer to red or has passed red or has reached red. Alright? So, hopefully that makes sense, that we see all of the galaxies in the universe have a red shift to them. We know they produce white light because that's the average light that's produced by most stars. But they all look red, and the only proof for that is that the light is being stretched out. Look at what my hand has to do. My hand has to move away from the other hand in order to become a red shift. So that is proof 1 that the universe started as the Big Bang, because if everything is moving away from everything else, that means that if you play it in reverse, everything's moving toward everything else. Okay? Alright. So, red shift, proof that the universe is growing larger, proof that everything is moving away from everything else. The next is another thing from Earth science, cosmic background radiation. The main point of this is that in all directions, we're receiving a microwave, which is a very, very long wavelength. Kind of like how we have red light is a long wavelength, blue light is a short wavelength. A microwave is an even longer wavelength, really, really long, so super, super stretched out. And in all directions, we're receiving this light. So remember when I talked about the Big Bang and atoms formed 380,000 years ago, which made light be released? That light was released as an orange light. An orange light, relative to a microwave, orange light has a very short wavelength compared to that. So as the universe began to stretch and expand, that light, that orange light stretched to a microwave. And today we have these microwaves coming from all different directions, and the deepest light we can see is this cosmic background radiation. And it comes from all different directions, and that is really just like the echo of the Big Bang. So like if you go into a cave and you yell, you'll hear your echo from all the different walls in all different directions. Same exact thing as this, except with light, not sound. We have a echo, a microwave echo, a cosmic background radiation that is going to be proof of the Big Bang. So to get beyond high school earth science, another piece of evidence that we have of the Big Bang is the amount of hydrogen in the universe. So what you can think of is hydrogen is the fuel for stars. And stars burn up or fuse that hydrogen to become helium. Now, as time goes on, if we're using all this fuel, we're going to have less and less and less and less fuel. So what scientists did was they actually calculated all of the stars that have ever existed and all of the hydrogen that they would need in order to exist and us to get to where we are now. And it turns out that the universe started with over 99% of everything was hydrogen. And as that hydrogen went into stars and fused into helium, we started losing that hydrogen. And now the universe is made up of 75% hydrogen. Almost everything is still hydrogen. 3/4 or 75% of the universe is hydrogen. But that other 25% that used to exist has now fused and become something different. All right? So what scientists did was they said, wow, if we add up all the stars and the amount of energy that they would have produced and the amount of fuel that they've used, then we can comfortably say that the universe is 13.8 billion years old. And the interesting thing about that is that the cosmic background radiation that we receive at Earth is about 13.8 billion years away. 13.8 billion light years away. And even the redshift helps us understand that when we do the calculations for the amount the light is stretched, the amount everything's moving away from us, and the distance between all these things, this points to the universe being 13.8 billion light years old. So, all these things are pointing back to 13.8 billion light years old, but let's get back to this hydrogen idea. So I like to use the gas tank analogy. Imagine this gas tank here is all of the universe and everything in it. The blue represents the amount of hydrogen in the universe. So this is 99% full. The gas tank is full, right? And this is the moment after the Big Bang. So we have 99% hydrogen. In this case, we have fuel in a gas tank. But as we use that fuel, time goes on, right? So what we can look at is the fuel eventually starts getting lower, right? And lower and lower. Just like how the universe begins to use more and more hydrogen as the stars fuse them. So at this time, we have 75% of the universe is hydrogen. But let's imagine that we discovered in a different case, like let's imagine that the universe was really like 18 billion years old. We would see that there would be less than 75% hydrogen, but if the universe was only like 5 billion years old, we would see that there is more than 75% hydrogen. So since the universe is 75% hydrogen, we were able to calculate, like I said, with all the stars and all the stars that have used hydrogen, that if the universe is made of 75% hydrogen, the universe is 13.8 billion years old. Final thing, and this kind of goes back to cosmic background radiation. This is the Hubble telescope here, and it's interesting that light doesn't travel like you think it does in like a room. Meaning that the moment you turn on a light in a room, the whole room is lit. But if we look at light traveling over many distances, then light actually has a speed that we can kind of think about. So to give you an idea, light from the sun, it takes 8 minutes from the sun to reach the earth. So that means every time you look at the sun, you're actually seeing light that the sun gave off 8 full minutes ago. The moon is 1 light second away from the earth, meaning that when you look up at the moon, you're seeing the light from the moon that's reflecting back towards the earth, and that takes 1 second for the light from the moon to reach the earth. So the idea is the further we look into space, the longer it takes that light to reach us, right? So by using very, very amazing techniques on how to measure distances using these things called supernovas, remember supernovas when stars explode, we're able to detect how far away something is by how dim the light is from certain supernovas. And using that, we're able to detect that the furthest light that we can see is just under 13.8 billion years ago. And that would be the cosmic background radiation, the really, really old stuff that we can detect as microwaves right now. Okay, so that is the lecture for the intro to proof of the Big Bang. Next we're going to learn about chemistry. This is a little more information than I thought it was, but check out the Nearpod. It's only 6 questions. Hopefully this makes sense. Send me some questions. Enjoy the mustache.